Just bear with me. Okay, so let's start today's sessions. Yes. So I hope we built KNN algorithms yesterday, right? So now what is imbalanced data? What is imbalanced data? Where the classes majority is very high, isn't it? If you say like 99% if the class is yes category, so 1% if the class is no category, then those called as what we called imbalanced data. So how come to overcome those imbalanced data? I will explain you later part, but morning batch 10 a.m. Today's 31st. I'm about to start machine learning. I'm sorry, SVM, but let's see. Extract text file, new file, and I'm going to use this KNN. Yeah. In this KNN, let's copy this and restart the kernel. So I wanted to talk to Archana. Just one moment. Not this one. 10 a.m. Archana, your code looks like fine. So can you please, you got your, just one moment. Please future predictions using logistic regressions, because I do see that you here. Can you compare, Sumit? You got the same output. I mean, your predictions of these 10 customers, 101110010. Logistic regressions, and then let's check. Subhasmita, you need to work out. No, you're wrong. I mean, Archana, please post your code part. I will review. Okay. Yes, Archana. Sundari, are you done? Chandrahas? Sundari, are you done? This one. Logistic regressions 10111010. No, that's not the 60%, 70% here. Okay, so that's what I'll tell you. You just you shared the code. Archana, you also shared the code. And if you not work, so I'll show you tomorrow or some other time. Okay. Yes, guys, classifier. I mean, you done this. 10. This is what I think you're correct. Both are same. Yes. Let's check. Let's wait. So what are the testing sample you considered? Archana and all those things. See guys, offline and online team, I'm giving some task, means that is very important, guys. Okay. I don't want you to listen whatever I'm saying. When I say something task, why not you work, guys? So very simple. This is what you need to work in the real time. You are going to predict the future without knowing a student is or customer is buy a car or not. So why don't you do this? Very simple. You not sit in front of the system for more than 3 hours. That is the reason. It's not works out. Again, I'm saying. Online guys, except Washim, why not you done, buddy? Yasin, why you not Jade and everyone? Pratyush, give me a few times. I'm sharing. Not you, Archana, that's okay. But I'll be sharing. Please share it, the task, and show me your results, guys. Chandrahas, you ask a lot of questions. Why you not doing, buddy? Okay, it's your choice, guys. Let me start the topic. I am least bothered about you if you do not work. Okay. So let me go back to the work. So yesterday we built the KNN algorithms, right? We worked it. Let's close this. Because if you do not understand, how do you learn all the packages, string, Unicode, data, stopwords, wordnet lematizer, and NumPy, BS, beautiful, so all those things. But I got failed to do that. No, Pratyush, no problem. If you try, that's what questions did I ask? You still don't know what questions I'm asking. Surprising. Still, you don't know what exactly questions I'm asking, what we're discussing. Strange, man. I'm saying we build the model and did you apply for predictions? If you take a recording, can you please listen and come back to me? Okay. Yes. Now let's do this and then let's restart my kernel and I'm going to build the model with, what is the by default nearest neighbor, guys, based on yesterday's discussions? 5. Yeah. So nearest neighbor is 5. So let me execute the code. And now I am asking what myself asked you. I don't understand, man, your English. I am asking what myself asked you. Just calm down. I'll speak with you after the sessions. Okay. Okay. I will speak with you after the sessions. All right. Yeah. Let's talk about this one. So here 95% without hyperparameter tune, isn't it? So has anybody done the parameters, guys? Hyperparameter, did you change to the neighbors to 6, 7? Anybody done, guys? No. So that's okay. So let's try to do this today and we will check. And what happened? I told you some of the tasks in logistic regressions. If the random state value changed to 0 to 41 and 100, what's gonna get? Can you close this? What I'll get, guys, if I change the random state? Did you try this? Okay. Let's check. If I change to 51, okay. So what is accuracy right now? What is accuracy right now? 95. Yeah, let's check this. 95, right? Random state 0. Yes or not, guys? I'll say at random state 0, at Archana, I will check. Just one moment. Okay, so just bear with me here. And I will open this one and edit with Notepad++. So in KNN, RF means not random state. RS is 0. And what is the 20% sample? 20% sample means test data. We got accuracy of 95, right? 95 percentages. What happened if I change this sample to 20 and random state to 51? Let's restart the kernel. Are we going to accuracy will increase or decrease? Everybody's agree? Increase or decrease? So let me check this out. So let me check this out. So let me this part. 91. Did you see, guys? What is the difference? Now, what happened if I change the random state to 100? Let's check this, restart this one. So all the time by default random state value should be 0. Understand now? Yes, guys. So this is the random state value should be 0 all the time. Yeah. So now let's check this out. Let me execute this last time. And now let me go for parameter tuning. So far, what would be the neighbors I've considered to build this model? 5, isn't it? So 5 neighbors we considered to build the model. Now let's check. Let me click this one. So what I'm going to do, I'm not going to add all these things. Weights is uniform. So let me check here. So n neighbor 5, let's copy and I can paste here. Understand? and then weight is uniform, and what else? I think what other weights, guys? Distances, we have two type of, I think one or two, yeah. Weight uniform, weight distance, algorithms auto, and all those things. And final, p equals to what exactly? This one, p equal to 2. Yes. Now what I'm gonna do, 2 means Euclidean distance, right? Now let's copy this, and same p equal to 2, and I will change the neighbor points to 7, because I am rather than taking a decisions from 5 people, I should take a decisions from 7. Yeah. So what I'm gonna do, so let's variable explorer, and let me restart the kernel again. And anything else? Let's check. Let's check this metrics. So I have Euclid distance metrics is already implemented. That's okay. Now let's see. Random state is 0 or 100. Let me change the random states to get back to 0 again. Okay. Get back to 0 again. And let's save the model. Let's file and save it. And then I'm not gonna till accuracy part and then execute. 95 itself, isn't it? What exactly? 95 itself. But now what happened if I p equals to 2? So let me check this out. Even the 0.5% increase also fine. Yeah. So I can say weight is equals to, let's copy this, and I'm passing here, and algorithms is auto. Now instead of auto, I think I should take random, because just 1 second. Default auto. So we have ball tree, KD tree, and brute force, all those things. So the by default is auto. That's okay. Tim, are you understanding or not what I'm doing? Yeah. So here metrics is default is this one. What is other metrics we have? So distance metric. Yeah. So see the document distance metric, or I can say what happened if I say change to 2 to 1. If I, what happened if I change 2 to 1? Yeah. And let me check to 6, and let's restart it, and final one I'll try. If not, then that's okay. 95 would be the, we can fix it. Okay. 95 would be the best one, and we can fix it. Online guys, are you understand? Yes, team? Yes, Bhumika, I think you joined from online. All right. Yeah. Okay. What's the best for calculating KNN Euclidean? Pratyush, as I said yesterday, Euclidean is best one. Pratyush, I already told you yesterday, right? Yep. Okay. So now here we go. So let me execute this one. Let's try 95 only. Okay. So I think that would be the least one. You cannot increase more. Okay. So this is what exactly the final KNN model. So in KNN, I think everybody's clear what exactly this distance is all about and how to calculate all those things, right? So project 27, I think somewhere I posted. Just give me a second, guys. Just 1 second. Logistic SVM KNN, correct. So once we're done with the KNN, I will share some of things to you. Just check this out. So everybody's understand the concepts, the algorithms, the logic, the math behind each and everything, right? Now, I wanted to show you something very important. Logistic with EDA. Yeah. Let's do this KNN. If you wanted to make some of the projects, you know, guys, you're talking about some of the college projects, right? Why can't you do this type of projects? Yeah. Let's discuss after the class. Yeah. So this is one. So introductions to KNN. Okay. And what exactly import libraries, data set, EDA part, data visualizations, declare feature vectors, target variable, feature engineering, feature scaling, fit neighbor classifiers to the training data set, predict the test set results, check the accuracy score, classifier metrics, ROC, AUC. Did I completed ROC, AUC? Okay, so let's complete today ROC and then I'll explain tomorrow SVM algorithms, right? So this is all results and conferences and references. Yeah. So everything is given up. Once you practice this, don't you think you completely deals with one project? Agree or not, guys? Everyone clear? So I mean, it's starting this one, introductions to KNN algo, how to decide the number of neighbors, as I told you. Okay, how to import the libraries, data visualization, split the data. So let's do this. All the explanations is given up here. Okay. Okay, so this one, import data set. We have the breast cancer, I think the Wisconsin data we have, and EDA exploratory data analysis, and rename column names. And then we talk about drop redundant columns, which is irrelevant attributes. Yes. Then we plot frequency distributions. I mean, to find out each and every plots informations like frequency distributions of values of variables. Okay. And it's very simple, guys. And finally, we build the model to check, do you have his null value or not? So this is to check. And it's a quite straightforward, guys. It's not a big deal. And finally, you can find out the what are the visualizations part, univariable plot, and then multivariate plot. And then we go for, we check the heat map. Yes or not, guys? Heat map is also given up here. Interesting or not? Yeah. So you can work also, these are the college projects, guys. It's and also declare features, but this is not for your resume projects. This is not your resume. Once you do this, you can figure out how exactly the feature engineering and missing variables and then assumptions, and then we can build your feature scaling and rest of things we're going to calculate. Yes or not, guys? So I think this you can work after complete the KNN. Yes, guys? Yes, team? So I'll share all the details. I hope it's pretty good one. So I want you to please take down this part and rebuild KNN classification model using k equal to 6. What's meant by that? Hyperparameter tune. So KNN 6 parameters we build, and we build the accuracy 97. K equal to 7. What is accuracy? 97, 86. Same also 86. For us also same things. But if you talk about by default 5, what happened? 97.14. Yep. By neighbors of 5 points, we got 14. But neighbors of 6, we got 97.86. Clear? And now by the neighbor of 7, what exactly happened? 97.86 by 8, same things. By 9, it's reduced. It's reduced. Yeah. So confusion matrix we build. After the confusion matrix, what exactly next step? The next step is classifications matrix, precision recall, and F1 score. And the next step is bias and variance. You will check before that also. That's no problem. Yeah. And the next step is AUC ROC curve. Okay. AUC ROC curve. What exactly this curve is all about? Can we discuss, guys? Can we discuss today, or we'll discuss SVM? Now let's see the AUC ROC curve. Okay. And then we talk about this one. So here, oops, just one moment. AUC and ROC. Okay, let's say we'll discuss tomorrow. Yeah. So I have to check this file somewhere. I placed it. Don't waste the time. Now, KNN part is completed, guys. KNN algorithms we completed, right? So let's close this. No. And if I go back to here, KNN is completed. So very simple. I want all students to please work on the future predictions, okay, for 10 records, and everybody has to work with 20% test set. Okay, how much? 20% test set, and you predict and show the results, everyone has to get same predictions. Everyone has to get same predictions, isn't it? Because same code, same accuracy. So of course, same predictions or not? Yes or not, guys? So everyone has to get same predictions for 10 records. I know it's not finding, but please spend time and research on it. So the one who already done, let's wait for everyone. In the meantime, we build other modules, and then we compare with all future predictions, and we validate. Yes, and we validate later. Team, everybody's clear what I'm saying? Why we use heat map and what is the importance of heat map and how to understand heat map? Please explain after class. Prasanna, sure. Okay. So no problem. Prasanna, I will tell you. Okay. So heat map, I think you asked before these questions. Okay. Sure, definitely. So now let's talk about this one. KNN we completed. Now the next one. The next one we have called SVM, support vector machine algorithm. Yeah. So today and tomorrow we will take these two things, and I'll explain very important topic today. Just listen to this. What exactly SVM? Do you remember SVR in support vector regressions? What we learned so far? Hyperplane, decision boundaries, marginal distance, and all those things. Clear? I hope you get it, guys. All those things we understand. Now, what's 31st? So the first, we will understand one by one. Let me tell you guys. If you see this plot, did you see? I have two dimensions, x-axis and y-axis. Okay. Now, x-axis, y-axis. One class is circle, one class is square. Okay. And what do I say? The line is split my data. Agree? The line is split my data. So if I see this part, this point is closer to the line or not? This point is closer to the line or not? So let me plot the line over here. Right? And this point is closer to the line. Agree? So these are so I can plot a parallel line to the hyperplane. Clear or not, guys? So I can plot the parallel line to the hyperplane. Now, if you see this, the distance between this hyperplane, what we call this one? What we called? Decision boundary or support vector. Decision boundary or support vector. Two things we called as. Now, from this distance, from this hyperplane to this distance is called negative. And this distance from hyperplane to decision boundary we call positive. Understand or not, guys? Yes. So now let's talk about this one next class. So here you may ask a question, sir, we can classify the data in multiple way. Why only like this way? Isn't it? I can classify my two data like this. Many way we can classify the data, isn't it? So let's close this and someone classify the data like this. Let's see what happened. This is a two part. This is use case 1. This is use case 2. Correct? I can classify my two data points like plot the hyperplane like this way. And also I classify the data by plot like this way. Clear or not, guys, everyone? So where do you see the distance is very high? As I said, where you want to drive your vehicle, guys, by NH road or by, street road, if you have a car. So you want to drive your vehicle in NH, whether it may be car, whether two-wheeler, whatever it may be. Yeah. So because the space is more, the maximum margin is more. Yes. So this is what. So in this case, what exactly happened? The distance is very high. So can I say Can I say M2 is greater than M1? M2 is greater than M1. We can say this because the marginal distance is very high compared between two support vectors. Yes or not, Wasim, Yashin and Avinav, everyone? Yes, guys. So the difference between two vectors is quite high. I mean the maximum. So that's why we called as a maximum margin hyperplane. But the interview question is, why only need to choose this? What is the interview questions? So let me write down here in SVM part, why to choose, why only required maximum margin hyperplane. There is some concept is there, right? So that's why we go for a. So if you say why only you need to drive your vehicle, so let's talk about, I'll give you a small example right now, and then I'll talk when I explain the math concepts, then you understand. Let's say this is NH road, right? And this way the heavy truck vehicle is coming from this way, and there is no place to cross this vehicle, isn't it? So this is the rules. The rules is whoever going this way, you need to go by this way. Whoever coming by this way, they need to come by this way. So what happened if the heavy vehicle is going this way? Let's say in the background some cars or two-wheelers are coming up. So how they cross this vehicle? How they cross this vehicle? So they will come back to this point and it will come back here. Agree or not? So for this point, this is error or not? For this point, these are error or not, guys? So if I have maximum margin, then only adjust the error. Then only adjust the error. Now, if I have narrow road, how do you think you can adjust the error? Is it possible, guys? No, that's why the maximum margin hyperplane is required. Understand, guys? That's why the maximum margin hyperplane is required. So I will tell you the math concepts behind each and everything. Yes, Prasanna, Chandrahash, Pratyush, Bhumika, everyone. I hope you guys are understand. Yes, guys. So what is meant by maximum margin hyperplane and why it is required? In interview, don't talk about this. In interview, don't talk about this, sir. If the train is vehicle going by this way, then he will say, take your vehicle and go that way. Isn't it? So this is just for an explanations which you to understand. But how do you communicate? I will talk about it. I will share you some of the equations. Minimum error. That's right. That's right. Even though not minimum, buddy, whenever the error is come back, it will adjust it. So how many error it will adjust it, those will tell you later part. I hope you understand why support vector has maximum margin hyperplane, not minimum margin, not minimum margin. Now, I hope you're clear. So this is this part, this math part, we will understand tomorrow. We'll understand tomorrow. But today, if you see this, what we understand so far, let's see. Can I called if the line is split my two data points linearly, can I called as LSVM? What we called? LSVM. So linearly separable vector machines. Can I call it? Linearly separable vector machines. Can I call this, guys? Yes, online team. Now, this is called LSVM. So this is called LSVM. Now let's talk about this one. When the hyperplane is split my two data points in equally, linearly, we called as LSVM, linearly separable vector machines. Now, okay, I'm introduced to another part. What is nonlinear SVM and kernel functions? Let's talk about this one. Now I'll plot one graph over here. So let's understand. So I have two dimensions. And I will say this is called square, square, and square, and square, and square, and square, right? This is, I'm sorry, this is circle, sorry. This is circle, this is square, yeah? Can I classify my data? Can I linearly separable this data? Let's say if I plot here, Rashmi, are you understand? Yeah, I hope you understand, guys. Yeah. So this one, so now if I plot like this, can I separately linear? No. If I this way, can I do it? If I do this way, is this possible? You can do anyway. This is not possible. This is not possible at all. So that's why this is called non-linear SVM. That is why we called as non-linear SVM. So an interview question, what is the difference between LSVM versus non-linear SVM versus non-linear SVM? Team, everybody's clear? What is the difference between SVM and non-linear SVM? Yes, guys? Now, the next one is called if nonlinear SVM, how to classify the data then? How to classify the data? So that means we can't classify? Yes, how to classify the data? Let's check. So let me introduce another concept called kernel functions. What is this? Kernel functions. What exactly the kernel functions will do? Kernel functions will change from low dimensions to LD, low dimensions to high dimensions. Means if I have one dimension straight line, I cannot classify my data, isn't it? But if I apply the kernel functions, this one dimensions I can apply to two dimensions, and I can split my data like this. Understand? So now, so by apply kernel functions, will convert LD, low dimensions, to high dimensions. Understand or not, guys? Everyone clear? Low dimensions to high dimensions. Do you remember what are the type of kernel functions we saw in regressions part? In polynomial, what are the kernel functions? Poly, sigmoid, and I think RBF, linear. Team, are you understanding or not, guys? Are you able to connect all these things? So this is now another interview question is which concepts you know which will, what is difference between PCA versus kernel functions? Anybody tell me? What is difference between PC and kernel functions? Very good. Very good. PCA is dimension reductions. Dimension reductions versus what is kernel functions, buddy? It is dimensions increase. Yeah. Increase the dimension. So, I mean, in PCA, HD to LD versus LD to HD. Team, understand? Will you answer if somebody asks these technical questions now? Online, guys, everyone, Washim, Jade, Yasin, Avilash, Avishek, Ajay, Argha, Ashish Kumar, Chandrahas, team clear or not? Pratyush, Sinduri. Team, I hope you understand. Yes, guys. So this is what exactly your technical questions, right, guys? So you're sometimes I do see most of the people after apply the job, they'll say, sir, they gave Python coding round. So Python coding round. The bad luck is if in the company, if Python guy asks you interview, definitely will ask Python coding, right or wrong, guys? Yeah. So this is, you need to be handle those things. So no need to worry for this one. Now the next one, I think we understand dimension reductions versus increase the dimensions. Clear or not this one? PCA versus kernel functions. Now let's talk about this one. Now let's see this. Yeah. So what we learned so far, guys, we learned support vectors, we understood. Hyperplane, we understood. Marginal distance, we understood. Linearly separable, we understood. Non-linearly separable, we understood. Kernel functions, we understood. All right. PCA, we already know this, and we find out the differences. Now the Another point I just wanted to cover up is called maximum margin distance hyperplane, right? So why this is called maximum margin? Why, what's so special about SVM? Did you see, guys? I will show you some of things when same techniques, I think, just one moment. Okay, same techniques how I'll explain to my great learning students, their PDFs are different. I'll show you sometimes, all right? So tomorrow we're going to talk about math, but let's can we build some social, this part as well? Okay, or let's talk about this one, math, if you allow sometimes. Can we complete this, guys? Can we complete this? Why so special about maximum margin hyperplane? Why so special about maximum margin hyperplane? Let's see this. So assume I have two data point here. Okay, so one side of the plane is positive, other side of the plane is negative. So let's assume this is the hyperplane equations, y wx plus b. Clear? And now I take two data points, single data points here. At this moment, this is the coordinates are 4,4 and this coordinates is -4,0. Clear? Now, if the slope is going towards this, the slope equals to 1. So I would say this. If this directions, the slope is -1, this is positive, the downwards is negative. So now wx plus b equal to 0 because the hyperplane is touched to the origin. Yes. So wx plus b equal to 0. So let's talk about this one. Case 1. M equal to -1, right, guys? Or m equal to -1, c or b equal to 0. Y equal to wx plus b means what, guys? W is -1 and c or b equal to 0. Clear at this part? Now y equal to w into x means cross multiplications. What is the w? -1, 0, x -4, 0. If I do a matrix multiplications, can I get output 4 or not? Can I get output 4 or not, guys? Yes. So we get output 4. So if one point is positive, all these points are positive or not? Clear? All these points are positive, guys. So this is case 1. So if y is positive, one moment. So all the point going to be always positive. Now let's come back to the another part. Let's come back to the another part. So another part is, in this case, what happened? 4,4 -1, 0, 4,4. This is negative or not? Guys, I hope you understand the two part. So this part is always be positive and this part is always be negative, isn't it? This part is always positive and this part always be negative. Yep. Now let's do this. So I think you know this part clearly. This is hyperplane, wx plus b equal to 0. Correct. And if the distance between hyperplane to support vector is positive, then I mentioned wx plus b equal to +1. I'm sorry, because in our calculations, red point we got positive, correct? Yes or not, guys? Red point we got positive. And in our calculations, the blue, this point we got negative, correct? So can I say this, wx plus b equal to -1? Agree or not? Wx plus b equal to -1. And this point, wx plus b equal to +1. Agree, guys? Now, how to find out the distance between, how to find out the distance? Can I say wx plus b equal to -1, wx plus b equal to +1? Can I say this? And if I apply minus, if I remove this distance from this distance, definitely I'll get a distance or not, guys? Clear or not? If I remove, if you negative the two distances, then I'll get the distances. So let's talk about this one. Let's go for here. So in this case, the distance is positive and the distance, this is negative distance, this is positive distance. Now I can finally write like this, guys. Did you see W transpose x1 and x2, -1 and -1? So if I solve this equations, can I get like this? W transpose x2 minus x1 of 2. Can I do this, guys? Can I get this one? Now, what happened? I can do this one. Let's check this out. Finally, if I add the weight, the norm of W in math, because we don't need to deep dive into it yet. So finally, what I can come up this one, let's talk about this one. So can I come back to the equations? W x2 minus x1 equals to 2, correct? Now x2 minus x1 is equals to 2 by W, isn't it? Isn't it? So 2 by W here. This part, I will get a positive value. I will get a positive value when Wx plus B is greater than equal to 1. True? I will get negative value Wx plus B when less than equal to 1. Isn't it, guys? So that's why the data is properly classified. Now, W and B, we got the max of 2 by W. So I'll fit this equations like this. This is called optimization functions. Means, let me tell you, you no need to worry about the math, but just its packages will take care of you, okay? But if you see W into B, max of 2 by W, because we have to optimize the functions. Each and every data point should be maximized to get a more error. Okay, so when I finally, in gradient descent, what exactly happened? We try to minimize the error or maximize the error. So let's do this here. Here I'm writing max of 2 by W means mean of W by 2. Can I write this? Because we're trying to minimize the error. We're not going to try to maximize the error to reach the global minima. Online guys, I hope you understand. Yes. So we're not going to try to maximize the error. We try to minimize the error. So what exactly? Finally, we're going to come up the equations as, just one moment. See, W into B equal to minimum W by 2. We understand, guys? Now, this is what the final equations, guys. Support vector machines not audible. Everybody's listen to me or not? Yes, guys? Yes. See, Chandrahas, everybody's listen to me. For you, it's not audible. Okay. Now, if you look at this, the final equations of SVM is minimize the weight by 2 plus CI means what? In the road, how many vehicles are passing the value? CI mean how many errors, plus summation of Ni equal to 1, summation Y means value of the error. I hope you understand. Yes, guys. So these equations would help you to maximize the distances between, maximize the error. So that's why when we see, guys, from sklearn.svm import svc, this equation is been called in the background. I hope you understand, guys. So this is what the final equations, and we need to remember this one. And in the formula sheets, if you see this, few students have mentioned this as an equations. Yes, guys. Team, everybody clear? So what exactly CI means? How many errors? How many errors means 1, 2, 3, 4. But count of value of the error means 1 plus 2 plus 3 plus 4 summations. That's why we call it as sum of the error. So that is the reason we say that in SVM, in support vector machines, what exactly going to happen? We minimize the error, guys. And this is what the support vector machines equations. Yes. Yeah. So we'll work code tomorrow. We will work on the code tomorrow. We will implement all the 4 kernels. We'll implement all the 4 kernels like this one: poly kernel, sigmoid kernel, RBF kernel, linear kernel. Any more missing, it seems? Anything else? I think another one is there. Anyway, let's check tomorrow. Let's check tomorrow. Yeah. Those are 4 kernels, 4 or 5 non-linear. Linear is there. Let me check tomorrow. Yeah. I think these are kernels we have tomorrow, and we're going to work on. We will work on the SVM tomorrow part, guys. Yeah. I hope you understand. Yes, guys. So yeah, so this is what SVM we completed. So we have few more things. I'll take more time for nearby's. SVM will complete tomorrow. And what is month? June 2nd week, we will discuss about resume. Yes. Yes, guys. June 2nd week, we'll discuss about resume. Okay. Yeah. The one who interested, yeah, I will share them. We'll have a lot of things and then we discuss. Yes, guys. Okay. Thank you. So did you see my few students, they've been applying such a long time, voice not coming. Oh, come on, man. Chandrahas, everybody, the voice is coming. If the voice is not coming, then it's fix your net connections, buddy. Understand? My one student, he cleared Amazon interview and Tiger Analytics. Let me show you. Mahesh, just one moment. Mahesh Naresh IT. He's completed students. I mean, it's a long ago. I think 8 months back he completed. Still now no jobs for him, but he's keep hunting. Any update, Mahesh? Yesterday, suddenly I think, okay, he was my best student. So I asked him, any update, Mahesh? So two company, Amazon, update soon. I'll update you soon. All round is complete, but HR is connecting soon. Amazon Tiger Analytics. Let's hope for the best. I wish him he'll get a good offers from. Both are excellent companies, isn't it? Both are excellent companies, guys. Let's do this. Let's do this. Okay. So I'll give sometimes these things only you will get an interview. Okay. And we'll see tomorrow. Thank you, guys, and have a good day. Okay. Yeah, please explain about heat map. Okay. So Prasanna, what is meant by heat map? When you plot the variable using, when you visualize the plot using many variable, we call it as heat map, right? So let me show you. Have you ever built this once? Guys, done. You can leave for the day. Yeah. So let me show you. Yesterday's notes share. Okay, I didn't share KNN. I didn't share KNN. I'm sorry, guys. I forgot. So today I'll share everything. Today I'll share everything. Okay. Yeah. PC, that link also I didn't share, right? I will share. I'll share. Okay. Yeah. So let me say, where is heat map? Heat map. Just 1 second. If you have many variables, Prasanna, you cannot show that in 2 dimensions or 3 dimensions, isn't it? Correct. So for those graphs, what is the correlation ranges? The correlation ranges from -1 to +1, isn't it? The correlation ranges from -1. So in this data, correlation of attributes with class variables, isn't it? If you check these diagonals, 1, 1, 1, the diagonals we are getting 1. If you see the diagonals, we're getting 1. So how to get these diagonals? So, thickness, and if you scroll down, just one moment. Let me zoom. Yeah. So if you see this, the thickness and thickness, we got 1, but thickness to cell size 0.64 percentages, correct? Understand? So what exactly trying to say, these all attributes are important attributes to build the model. So you need to consider these attributes to build the model. Yes, Prasanna? So these attributes you need to consider to build the model. Yes, guys? Yeah. Okay, Prasanna. So once I'll share this one, you can build and still not understand. Okay, then we will discuss again. I'll give you access, then we'll speak each other. All right, Prasanna? Okay. Thank you. Good. See you tomorrow. Remind me about AUC ROC curve. Okay, we'll complete this and then we talk about SVM codes. Tomorrow we'll start on sharp 10, guys, because today the demo was completed for 8:30 AM batch. So we will start on time 10. Okay, we'll go up to 11:15. Okay. Yeah.